Okay, so we are going to determine, we're going to look at A and B and determine if they are geometric sequence, yes or no. If they are, we're going to identify what's called the common ratio. We'll talk about in just a second what that means. So here's what you do. So when we were doing an arithmetic sequence, think about what we did. In order to find the common difference, we took two consecutive terms, we took the second one and we subtracted the first one. And that's how we found the common difference. In this case, because we're looking for geometric, we're going to take the second term and divide it by the first term. So in other words, and I'm just going to kind of keep track of what I'm doing over here. So I'm going to take, in this first one, I'm going to take 64 divided by 256. I'm just going to reduce that. That's 1/4. Now I'm going to check. What I want to happen as I go through is I want each pair to work like that. So now I'm going to take 16 and divide it by 64. So 16 divided by 64, that's 1/4. You can kind of see what I'm going to do now. Now I'm going to take 4 divided by 16, that's 1/4. Obviously, I'm going to take 1 divided by 4, that's 1/4. So, because this quotient is the same every single time, this is geometric. So my conclusion, this is a geometric sequence. And my common ratio, in other words, the number that I'm multiplying to each term to get the following term is 1/4, right? If I take 256, I multiply it by 1/4, I get 64. If I take 64, multiply by 1/4, I get 16, so on and so forth. So my common ratio in this case is 1/4. Let's look at the next one. So for this next one, take second term, divide it by first. I get 12 divided by 6, which I think you'd agree is 2. I take the next two consecutive terms. So I take 20 divided by 12. That's clearly not 2. Conclusion, not a geometric sequence.